Okay, another eBay find. I've got a bunch, actually, I don't know if I even have any actually on this bench before I open my mouth. Yeah, surprisingly, I don't think I do. I don't have any Sencore equipment currently on this bench. I do have a lot of Sencore equipment, have a lot of it over on another bench. I have a couple of their Z meters or inductance and capacitance meters. I've really liked the Sencore one. One of the main reasons is I like the old vintage equipment like this is I like LED displays, nice big red displays. I mean, you can hook up something to this and walk 15 feet back and you can still read the display. It's crystal clear. I just like how easy they are to read. It's also very easy to use. Now I have some of the, I wouldn't call them modern, but they're more modern than this, some of their LC meters, and honestly they're a lot harder to use. Don't get me wrong, they're easy, have lots of push buttons, but this is extremely simple to use, and that's one of the reasons I like this. This is as the title says, a Sencore Capacitor Analyzer. This is a CA, grab the front part of the cabinet here so you can see it, CA55 model. I've got one of these already. One of the big advantages is, but this one, it came, it's not in the picture here, but take my word for it, it did come in the original box. A little bedraggled, but you know, if you were as old as this thing, yeah, you're probably a little bedraggled too. I know I am. But this one is in about as close to mint condition as you can get. I did just a tiny bit of cleanup work with a little bit of glass cleaner and a microfiber towel, and yeah, it looks great. The only thing I really have to wipe down still is the power cord. It's still a little bit dirty, but the meter itself is just in amazingly good condition. What was really nice was it came with all of the manuals, all the paperwork, and all the test leads. So, I mean, it even came with the accessories. I mean, it came with the factory low capacitance, let's see there, low capacity test leads. So when you hook these up, they don't add a lot of additional capacitance to the circuit under test. Comes with the nifty little adapter here. Really nothing more than just a set of alligator clips, but it's a way, because with these test leads, because they're mini grabbers, well, of course you can't grab onto big terminals with that, so all this does is basically convert your mini grabbers over to big grabbers or alligator clamps. And if you look down in there, it's kind of probably hard to see, there's just two little eyelet terminals down in there, and you just clip on to them like that. That's it. It just clamp on. Has the spare fuse, even comes with an Allen wrench if you ever have to take the knob off. Yeah, they even include a, what is it, a 16th inch, I think. The fuse just broke. Look at that, dropped the fuse out of the bag and the glass shattered. No biggie. I got hundreds of that size of slow blow fuse, but yeah, even came with a 16th inch Allen wrench. Has two of these. There's actually a spot in, actually it's on the back, still on the back of the meter, I was thinking it was on the back of the cabinet, little holder here for one to snap in, but to even send a spare along. So if you want to use one of these, which I don't recommend reforming capacitors, but if you're so inclined and you want to use something like this, because this does produce up to 600 volts on the output, so you can reform capacitors with it. The problem is when you're using the capacitor leakage test, which is what applies the voltage to the jack here, you have to hold the push button in. It's not a latching switch, it's spring loaded, so you have to hold it in. So they include this little thing, basically a piece of plastic with a rubber bumper on each end, and when you have it in the cabinet and you have the bail handle pushed down at the front here, you can actually wedge this in. It's what it's designed to do. You push this in, it pushes the button, and then you drop that down in between the handle, and it just holds the leakage button pushed in. That's kind of a novel idea. Like I say, I don't recommend reforming capacitors. If a capacitor's that bad, you just need to replace it. Biggest advantage here was it came with the manuals. I don't know what it is about Sencore. Getting manuals for some Sencore equipment, you've got a better chance of finding that elusive pot of gold at the end of the rainbow. This came with everything. The other one that I have, I ain't got no manual. Well, now I've got one. For no other reason I bought this. Well, two reasons. I really like the meters. Simplicity of use. Well, three things. They never seem to fail. Simplicity of use. And the third reason was it came with the paperwork. So it even comes with the catalog. So this is the 1979-1980 edition. So that's obviously when this came out, because this is the sales brochure that came with it. And this cost, CA55, cost $495 back then. I do have that one, actually. I do have the LC53, and also had the other ones too, the more modern ones. But yeah, it has all the original, all the other equipment that they made back in the day at the same time, power supplies, picture tube testers, TV analyzers, AM/FM stereo generators. I've got one of those hoarded away somewhere. I'm not sure where in the heck it's at. All the tube testers, yeah, ringers, even has the CB analyzer. Don't have one of those, but I do have two of those little performance testers there. Basically just a watt meter, SWR meter, and the frequency counters. And I think I have every frequency counter that Sencore ever made. But then it has some other little sales brochures here. And no, don't ask me to scan all those because I ain't got nowhere to put it. And besides that, I can't scan. I can scan pretty big, but I can't scan this schematic. It is the size of a poster. So what I'm going to do is I'm going to open up and to every page, and it's the other thing, the manual's a little bent because it was in the box, but I will open this up to every single page. Stop for a second. So if you own one of these, so you can use this video as your reference. I'm not, like I said, I'm not going to scan all this. Don't ask. Don't bother. All I'm going to do is I'll open it up to every single page and I'll stop and hold it there. So you can just, freeze frame. If you ever need to use this video for reference, just go to the video, fast forward through to whatever page you need, and you'll be able to see it. So here's some other, yeah, just sales. This is basically, I don't know why they need to send this to tell you why this instrument's so great. Obviously, you've already bought it if you have one. The original hang tag off the cord, the warranty card, which obviously never got sent in. You got to remember, these came with a lifetime, pretty much, I think everything Sencore, they had, what do they call that? The lifetime 100% guarantee or something like that, yeah, right there. Backed by Sencore's 100% made right lifetime guarantee. Yeah, woohoo! So, reason it's pulled apart, as with anything vintage and electronic, the cap's got to go. Well, this is a capacitor analyzer, so yeah, of course it's going to have some caps in it. So the electrolytic capacitors definitely got to go out of this thing and have to be replaced. Luckily, there's only 4 of them, I think, in here. 1, 2, 3. There's another one hiding in here somewhere, yeah, right down there. So we got 1 down there, 1 right here, and 2 in the back. And yeah, it looks like that one may actually be starting to swell up a little bit out of the end, the rubber plug there, yeah, where the lead comes out, it's getting a little, looks like maybe the oil may have started to seep out. There's just some signs of gunk on the end there. So yeah, it's due to have the caps replaced in it. Nice thing is, man, this thing's spot on. They don't really need much for calibration. There's only, I think, 4 or 5 adjustments in these. We got 1, 2, 3, 4, and 5. Yeah, there's 5 adjustments. Like I say, I will. Oh no, 2 more over there. So total of what? 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, total of 6 or 7 adjustments. Good Lord, I'll get it right. And that alignment procedure is in the manual. I will show that in the manual. But yeah, so I want to recap this and put this on this bench. The only thing I'm going to do is modification-wise, I'm going to remove the handle where I'm going to be sticking this here on the bench. If I leave these handles on, this sticks out just too much. I got like 8 1/4 inches, and this is like 8 3/4 inches wide to the outside edges of these. The cabinet's like 8 1/4, and I've got like 8. It just barely fits where I want to stick it. So yeah, the handle's got to go. And honestly, a lot of times I just remove the handles anyway. I never use them. They always get in the way. They're either swung in the back, get in the way. I don't need them in the front. Like I said, I don't reform capacitors, so I don't need the handle on there to be able to hold the button in anyhow. So yeah, I don't have. Besides, if I wanted to do that, I have power, high voltage power supplies I could do that with. So let me just slide this off the bench here, and I'll show the schematic now. So if you have one of these, get ready to hit the pause button. So here's the parts list. Make sure we get this in view. Let me rotate my viewfinder down. So get zoomed in a little bit more. So there's not too much. There we go. so there's that page. And if you want to, you can just fast forward to we get to after I show all of this. There's that page. Like I say, you can just pause the video. Obviously, there's the cover. Nothing to see on there. Okay, here's the layout diagrams. I'll even zoom in a little bit. There's the, move the camera down just a hair there. There's the layout diagrams. And it's nice that they do have these circuit traces also on the layout diagrams, which makes troubleshooting really nice since they have the shadowed traces layouts there. And then the display board. Front and back of the display board, which just plugs in to an edge card connector. And then the schematic. It's huge. I have no idea why in God's name they made this thing so stinking. God, can I get the camera up high enough? Oh, just barely. Yeah, there's the schematic. Yeah, there's my hand. I mean, they've got this thing so big. And look at the size of a resistor on there. Whew. So I'll leave it here for a second, and then I'll zoom in a little bit and pan around the schematic. So try and get that way if you need a little bit more detail. Try and get the camera straight down on it. Like I say, don't bother asking me to scan this because it ain't going to happen. What you see here is what you get. Be thankful I'm doing this. Just falls off the page there a little bit. Everything you'd ever need to know about this thing, you're looking at it right there in the schematic. Okay, so now you've seen the schematic. This can now get stuck in a filing cabinet till the day I die and gets sold at auction. Okay, now the owner's manual. Man, this thing hasn't spent the last 30 plus years rolled in half in the box. Nothing special here. Okay, let's get. That looks pretty good right about there. There's the index, or table of contents. Like I say, as far as actually using it, a chimpanzee could use one of these things. They're so easy. Pretty self-explanatory. And yeah, actually it looks like it came with every single accessory. It actually is supposed to come with two of the little stoppers there. Even there's the little holder that holds it on the back of the meter up there. Yeah, it's really nice. Came with every single accessory. And the leakage chart is actually on the cabinet, has the pull-out, like all Sencore equipment, has the little quick access pull-out card on the bottom. Oh, speaking of which, I do have a piece of Sencore equipment on this bench. I've got the stereo PA amplifier over there. Just dawned on me that it has a pull-out chart. I was going to say, my God, I was sitting here thinking, I was pretty sure I had something Sencore sitting on this bench. Shoved over there in a corner. And one of the really nice things about these meters, like I say, they seem to last forever. I've never had a Sencore, actually anything Sencore, break on me. Very reliable. But one of the things I like is this meter is obviously hardly ever seen any use, hardly any, and it's accurate. I plugged it in, turned it on, grabbed a couple reference capacitors that I have. Dead nuts on. The only thing that does need to be calibrated, and speaking of calibration, this is the part that's probably most important to everybody watching this if you own one of these. This is the calibration procedure right here. So this is the page you're going to want to zoom into and and read. The only thing in this one that really needs to be calibrated is this right here. The probe compensation 0. I think that's internal meter reader or whatever it was. No, right here. There it is. I'm looking through the viewfinder. The lead 0 centering. It's not perfectly centered, so I do need to calibrate that. But as far as capacitors, I tried all the capacitors, and yeah, worked just fine. There's the layout. So yeah, you have the relay adjust. That's a trip. Capacitors, the 0, and then a meter cal control over there. And not that you probably really need to see any of this, but yeah, the fundamentals of what a capacitor is and how it works. So basically, the science of capacitors. Sencore always did have really nice manuals. Actually, B&K also did too. You know, you buy it. Back in the day, you'd buy a Textronics or some of the ultra premium equipment that was made back in the same day that this stuff was sold. You get the really expensive equipment. Yeah, their manuals are hard to read. They're vague, and they assume that you went to college for 6, 8, 10, 12 years. You've got two PhDs and a doctorate in different electronic fields. Where Sencore and B&K it's not like it's cheap equipment. Like I say, they work really well. They're well built. But they were designed and they laid out their manuals really well so that someone that has absolutely no idea, like with this, what a capacitor analyzer is or how to use it, you read this book from front to back, that's all you need. It's all in there. It even tells you what a capacitor is and how it works. And it's just the warranty page and then the back cover. So there you go. So let me get this thing recapped to get those 4 caps out, and then once I do that, I'm going to do the alignment for the meter 0 knob right there, so I can get, or the lead 0 knob, I'll get that calibrated, and then I'll actually show this thing working, and we can go ahead and actually test those 4 capacitors that are in it that I'm going to remove. We'll just test them and see if they are bad. They obviously haven't exploded. One other interesting thing has nothing to do with this capacitor analyzer, but I'll just show them anyhow. I was running out of these. I was down to 3. Well, I just got 3 more. Found these on eBay. Back in the day, Radio Shack, every town had one, seemed like. These little clock modules were actually used in some CB radios. And they have a tendency of being shoved into really tight, confined areas, and they get burned up. The boards will get damaged because they have a voltage regulator on the back of them, they get trapped. But I discovered years ago these are the exact same ones that were used in those radios. So anytime I see these things, I buy them, and I found 3 more on eBay. So these showed up today too. Really nice to even come with the schematic, the full diagram documentation for it. But yeah, so in any case, let me get that analyzer back up on the bench. I'll change the caps, and then I'll just show basically how it works, how it's used. Like I say, it's, what would you want to say, so easy, even a caveman can do it. But really nice meters. Like I say, they just seem to hold calibration forever. This one's no exception. This obviously was sold probably in 1978 or 1979, 1980. Well, it'd have to be, says 80, so probably right around that era. And it's dead nuts on. I mean, that's one thing I just love about the Sencore equipment. Pretty much every piece I've ever owned, be it inductor analyzer, capacitor analyzer, multimeters. Now, signal generators, yeah, you'll usually have to calibrate frequencies because crystals are going to drift. But measuring devices like this, yeah, they just never seem to drift. The way they have their circuits designed, they just stay rock solid for decades. So, in any case, let me get to it, and I'll be back. Okay, so I changed out the 4 electrolytic capacitors in it. Did run through the calibration procedure, which, like I say, it's only a couple adjustments, because it only does one thing, test capacitors. I did go ahead and test the ranges, because like I say, I do have a capacitor standard here, and tested it. I did make slight adjustments to it, but yeah, the capacitance actual measurements were within the tolerance. So if you were to go by the meter's accuracy as the manufacturer's advertised tolerance, it was still within its tolerance. But I did make some very fine-tuning adjustments to that. My main thing was I needed to adjust the lead 0, which allows you to hook the probes up and then adjust for 0, because actually, like right now, you put it in and actually how it functions. So there's 2 buttons here that select types of capacitors. The first one is aluminum electrolytics. The other button is for all other types. Doesn't matter if it's ceramic, a polydip, a foil, mica capacitor, all the other ones with that button. You have a leakage button, which actually applies whatever voltage you have set up here to the probes. And anytime you get above 25 volts, you get into this red scale. You'll see the red light flashes over here. That lets you know that there's 50 volts or higher on these probes. So, and right there, caution, do not hold the capacitor or this, while you have it, while that light's flashing, because, 50 volts, yeah, maybe not so much, but you get to 100, 200, remember this thing goes all the way up to 600 volts, you could get a nasty shock across there. Granted, it's current limited, but still, you could get one hell of a nasty shock across that thing. And actually, I guess with the what's it limited to? 100 microamps. So that is very low. That's actually within the safe, not kill you zone, at least for all others. And then there's the actual capacitance value, which tests for how many microfarads, picofarads, whatever, depending on the capacitor, whatever range. So if we check the actual capacitors that were in this thing, so here's one of them. This is a what is this? A 2000 microfarad at 25 volt. So I have the meter set to 25 volt there, because we'll test for leakage and for capacitance. Now I've already zeroed. Let's just make sure they're still zeroed. So what you'd normally do is you'd put it on, whatever you're going to use, hit capacitor value, and you would adjust this knob to get, here I just turned it. You can see it's now reading 8 point. Oh, quit moving around. Just that, so not that it really matters a picofarad or 2 when you're measuring into the thousands of microfarads of capacitance. Usually you'd only really worry about zeroing this when you're testing very low value capacitors, only a couple puff. But anyhow, so let's hook this up. And yes, this one's definitely bad. If you can see the bulge, actually both of them, the whole end of this one's bulging out. You can see the white residue all over it, and this one you can see is bulging in one side. So that's probably, if I had to guess, that's where the vent is in the little phenolic board that's in there. But we'll get that hooked up, and it's an aluminum electrolytic, 25 volts, which is what its maximum rated voltage is. Push capacitor value. Remember, that's a 2000 microfarad capacitor, and you can see it measures at 2750, so it's a lot higher than it's supposed to be. And then test for leakage, and we have a flashy display. Now, the flashy display means it's exceeded the current limit, or the current that this meter can supply to the capacitor. In other words, it's shorted out, or it has an excessive leakage. This can supply up to 10,000 microamps maximum to aluminum electrolytics. That's what it's current limited to. And 100 microamps maximum for all other capacitors. So that means when that's flashing that there is more than 10,000 microamps or 10 milliamps being supplied out to that capacitor. Now sometimes, another thing to remember, it's a fairly large value capacitor, so you may need to hold the button in for a while. That's something else you'll find with electrolytic capacitors when you're doing test, because the capacitor has to charge up. So it's going to be drawing an excessive amount of current while it's charging. But yeah, this one's just, yeah, it's it's not charging because it's just not coming off the flashing display. So yeah, that one exceeds 10,000 microamps of leakage current. So definitely a bad cap. Like I say, we can just look at it and see it's bad. Same thing goes with this one. We can just look at it and know it's bad. And this is a, peel back the foam, a 1000 microfarad at 25 volt cap. So we just leave our voltage range is fine. And the value is 1500 microfarad. And the leakage current is, again, flashing. And there. I was going to say, this one was actually fluctuating back and forth when I tested it originally. So yeah, it's borderline. It's right around that 10,000 microamp leakage limit, so it's tripping in and out, but it's just not charging. It's, yeah, it's bad. Again, it's obvious physically. You can just look at it and see that it's bad. And let's grab this other now. Actually, this one I can't test because I trimmed the leads off so short. That one was a little bit of a chore to get out. But we can test this last one, and this one is I think a 50-50. Yeah, 50 volt at 50 microfarads. So we can test capacitance value. We can see that one's higher than what it's rated for, which usually capacitors, most electrolytic capacitors, if you look at them, you can see this one's 2000 microfarads, 25 volts, and it doesn't have a percentage on it. Well, that's kind of strange. Most of them do. Does this one? This one doesn't either. That's actually, I guess, more commonplace nowadays. They'll have the percentage or the tolerance for the capacitor. So don't be surprised if you see it higher than lower than what it's rated, especially electrolytics. That's fairly common. But yeah, that one's testing at like 62.1, 62 microfarads. Now we can increase the voltage to 50 volts because that is a 50 volt cap. And we can check for leakage now. And we can see 180, 130. Now that's the capacitor charging, and it's also going to be reforming because it is an old capacitor. So the longer I hold that button in, the lower and lower and lower that leakage current's going to get because it's slowly reforming that capacitor. Now, like I say, I don't like doing that to, reusing old capacitors. That's why I just replace them. I'm not going to waste my time reforming a capacitor just to have it fail a day, a week, a month, or a year from now. So yeah, we can see this one's at 10 microamps. And there's a little chart. As I said, all Sencore equipment seems to have these little handy pull-out charts, which is nice because that way you don't lose it. But so that capacitor's 50 microfarads at 50 volts. So if we look at 50 and then come over to 50, we can see the maximum allowable leakage current is 300 microamps. This one was showing 10 microamps, so that capacitor is still fine. There's really nothing wrong with it. Like I say, still going to change it. I'm not going to take a chance. It's an old cap. So, now if we test a newer capacitor, so, here's a brand new, so I don't forget, move my range back down to 25 volt, because this is a 1000 microfarad, 25 volt capacitor. And you can see its value, 960 microfarads, 960, 970, hovering right around there. And then if we test for leakage, we can see it flashed for a few seconds, because like I say, it's a good cap, so it's got really good storage capacity. So as it's charging up, you're going to see the leakage current drop. Now, like I say, fairly large value, 1000 microfarads, so it's a good size cap, so it's going to take a good bit of current to charge that guy up. And it's going to continue to drop and drop as you hold. And the larger you get in value, the longer it's going to take for that to happen. If we put a 2200 or a 3300 or even a 6800 or a 10,000 microfarad capacitor on there, it just takes progressively longer and longer and longer for the capacitor to charge up, because this is current limited, so it can only supply so much current to that capacitor at a time, and it's slowly charging up. And you can see we're 10 microamps now, 10, 20. So obviously a good cap. One of the other nice things about this meter is, unlike some of the older tube type capacitor analyzers back in the day, which I have and I've done some videos on, one of the problems with some of those, not all of them, but some of them, the leakage, there can still be voltage on there. They don't short out the leads after you release the button. Some of them are spring loaded. So some of them, if they don't have that spring-loaded switch, you can leave it in the leakage position so there's voltage there. You could then mistakenly come down here and grab this thing and electrocute yourself. This one, again, has the spring-loaded button, so as soon as you release the button, it shorts out the terminals here and discharges the capacitor. So we can also test this against a much newer meter. Let's remove the probes, take off my little dust cover. So if we take that capacitor now, which actually, what did it test at? What was it, 960, 970? Yeah, 970. So we'll now remove that. There you go, 963. So right in line with what that one tested. And now we can test actually some other capacitors. So here we have a foil type non-polarized capacitor. This is a 0.68 microfarad at 200 volt. So let's stick this on here. So we need to put this to the all others because it's not electrolytic. We'll test its value first. And you can see it's 0.664 or 664 or 0.664 microfarads. And now what I like to do is, now I know this is a new old stock capacitor, so I know it doesn't have leakage, but ideally what you should do is, if it's like a 600 volt, or this one in the case, this one's a 200 volt capacitor, I wouldn't want to automatically go to the 200 volt range, hit leakage, because it may be shorted. So I usually like to start off at a lower range, so like 50 volts. I'll hit capacitor leakage, and you can see it's reading 1 microamp. Yeah, nothing. Yeah, 0 to 1 microamp. So I'll go up to 200 volts now. So now there's 200 volts across those probes right there, and you can see our leakage current. You see the initial spike when I first push the button in. That's the capacitor charging. Even though this isn't an electrolytic capacitor, it still does charge. So that's why you see some current when you first push the button in, but once it charges, it goes down to 0. So yeah, a good capacitor. So actually, what did we have for a value on this? What was it? 664. Yeah, 0.664 microfarads. So now let's stick that. And look at that, 663.9. Doesn't get much closer than that now, does it? And let's check one last one. What did I grab here? I don't even remember. Oh God, the ink's almost rubbed off of that thing. Oh, looks like a 0.0082 microfarad. Or 8,200 picofarads. Or no, yeah, which would be 8.2 nanofarads. So we're reading 8,446 nanofarads. And 8,360 picofarads, or 8.3736 nanofarads. So again, very close to the other meter down here. So that's it. That's what this does. It tests capacitor's value and leakage. Like I say, I just like meters like this. These meters are nice. Don't get me wrong. Extremely accurate meters, really nice. I just, when it comes to high voltage stuff, if it's a high voltage capacitor that's rated at 500 volts, honestly, I like to be able to check it at 500 volts. I like to be able to turn the knob there, put it on 500 volts or 600, or in the case of this one it was 200. So I can physically test it at whatever voltage I want: 3, 6, 10, 15, 25, 50, 100, 2, 3, 4, 5, and 600 volts. So if it's a 200 volt cap, I can just spin the knob around to 50, 100. Actually, I do need to rotate this knob a little bit. It's just slightly off. I guess that's why they supplied the Allen wrench for the set screw. But I can put it to 200 volts, test this at its rated voltage. There's no ifs, ands, or buts. If there's any leakage in this thing, it's going to leak when you put it under its maximum rated voltage. So there you go. There's just a quick video on a Sencore Capacitor Analyzer model CA55.